Hello, we're going to talk about a cubic meter of space and time, and in billions and trillions of cubic meters of space and time on this planet, if not more. Okay, so how often do you get to oil your equipment, huh? I did. Okay, so where was I? Talking about that, okay? Oh, just look at this stuff. Wow. It was built in space and time a long time ago, right? Oh, the gears and stuff. Oh, so cool, huh? So, what am I leading up to? Going back to Tesla's detectors with coherers. Do you know what a coherer is? Probably not. Coherers and lamp black on glass with a needle moving along, giving a display of weird frequencies. Tesla did. Okay, so this will stand up to an EMP pulse, but modern stuff most likely will blow up, but it can be shielded. But you don't take into account of hundreds of subatomic particles, right? There's hundreds of them, and they were working in field mechanics and RF and energy, and you start manipulating those special pieces, special subatomic particles. They bunch up maybe or do other crazy things. So we know that ELF radio will affect cosmic rays, right? Right. So we'll turn this guy on, show you what cosmic rays sound like, right? Let's find out where I turn it on, right? Right. Wow. This guy is used to that, you know? R390s and vintage other things that are very old that I use. That's the tube I got from a very well-known scientist who isn't written up at all anywhere. Dr. Peter Kokoschnik was a nuclear physicist and understood what I was talking about. Well, how do you shield that stuff, huh? In modern instrumentation, this is kind of not a war, but an explanation of modern stuff that burns up in a certain area of a cubic meter of space-time. This is kind of cool. So anyway, I guess we can turn them off, making my point, trying to. That's off. That's off. That's off. So what do you do about neutrinos? All the different neutrinos and bosons and other interesting pieces and parts of the cosmic cubic meter of cosmic energy. These will handle it well. If you're manipulating those fields, let's say, which I believe explained to me I was doing, modern stuff will just burn up. I already had it burn up. A crown amplifier couldn't handle it, where other amplifiers will handle it. Okay? So if you have a modern thing you're trying to do something with, maybe like a computer, won't burn up. But once you start moving those fields, whichever the older stuff is used to, okay, I mean used to, it was built in that time frame before people knew about subatomic particles. So you're going to work gravitons. Oh, okay. Or neutrons. Oh, okay. What if you're using fields to interact with them and creating bunched up particles? Is there shielding for that in modern equipment? I don't think so. We know all about EMP and ELF, high-powered ELF. Seems that these old machines seem to like it. Okay. As I said, ELF interferes with cosmic rays. It keeps them sort of. That's an example. Okay. So you're dealing a hyper-power circuit, like I was doing, still doing. These will handle it. On defense of, he just uses old electronic stuff, old stuff and all that crap. Oh, how interesting. Three-phase Variac, high voltage stuff. Boom. So all this stuff, here's one of my atomic ray guns, so to speak, with Dr. Wilson of Canada's Defense Department, is highly interested in trying to explain to Dr. Kuhn. John takes those particles out and does something with them and blah, blah, blah. Okay. Which I've been doing. No ill effects so far. So you got a modern piece of stuff like this. It still works. And that'll just burn up in a very dramatic demonstration. It's not burnt up yet, it still runs, right? Little spectrum analyzer. So that would most likely burn up. Whereas this one would not. Okay? As witnessed by myself, maybe Dr. Wilson. This is real stuff. Used to it. There's a lot of subatomic particles that are moved around like a boson, and even a laser design was based on that, called a Baser. Dr. Yale. So all this stuff was built in times when they were doing nuclear testing and many other things, right? So these folks don't really realize that a cubic meter of space-time contains a lot of different things. Not just cosmic rays, but other rays. Once you get alpha, beta, gamma, they can be manipulated by magnetic fields. How about other things like tardons and protons and neutrons? Do you know a spoonful of pure neutrons weighs many tons? You don't know that, do you? No. No, you don't. So I'm taking a lot of chances working with this stuff in regards to manipulation of particles, meaning that they can bunch up or be accumulated at a different spot. It causes major effects, as I have seen and heard on certain things. So these guys will handle it very happily. So, may I suggest you study up on coherers, nickel chips and glass tubes, special glass tubes. Different metals react to different fields, electromagnetic fields, and that kind of thing. After all, I use VLF and ELF transmissions. I use disruptive discharge transformers, which affect the environment very, very heavy. I studied this when I was a kid, come on. And a lot of stuff goes smoke and fire, that's solid state, experienced it a number of times. So that's why I have all the good Navy stuff. Well built, made in the same time period as things that were made up later on. Things were just like plastic stuff, you know. Solid state stuff can't handle a cubic meter. Oh, this will handle a cubic meter along with many EMP pulses and other crazy things and nuclear stuff. That's why the Russians kept their vacuum tubes gear. So next time you make a stupid statement about, oh, John, that's uses old Navy stuff. Old Navy, yeah, right? Stupid. Really stupid comment. But no, I know what I'm doing, exactly what I'm doing. And I'm very respectful of those crazy fields because I know what they can do. Right? I know what they do. And you gotta be damn careful so you don't get hurt yourself, too. What does it do to your electrolytes in your body and like that? All the other atoms and atomic particles. Yeah, this is cool, but it can be dangerous if you don't know what you're doing. Right. As well as this piece, surrounded by magnets, magnetic field. I was trying some stuff a little while ago. Where did it go to? I don't know. Down here, I think. Yeah, this thing. The upcoming new metal sample. No effect yet on it. Oh, a little bit. But that's affecting metal. Why? Because of the relationship between what I'm doing, a subatomic level, as well as the metal here matching up to its atomic resonance and that kind of thing. Okay, well, I may be wrong, but who knows? Oops. So I was in a great day of making a lot of samples. Some were captured on video, some were not. So when it affects the gravitational gravitons and tardons and chronons, of course something's going to move around or fly up or melt or turn into jelly. Right? Certain scientists on that over time seem to know that. Even Desi's student wrote up a report. When I was in Germany, they have also an Esquire magazine article of 4 pages about myself, Roland Brito, and his brother, Bernard. Oh, do we get a reading inside this heavy-duty container? Of course we do. These particles seem to allow it to go through things. So, you can try all you want. But you should study Tesla, the ARRL Handbook, Steinmetz, Dr. Robert Golka. If you can find any Peter Kokoschnik stuff, great. He's an atomic physicist. And that big Geiger counter he was gifted to me by his wife, Dr. Margarita. Those were his favorite tubes, and I have the other tubes for neutrons. And it does collect once in a long time, especially calibrated tubes. Oh, Still recording. Here's a powerful magnetic field. What does such a powerful magnetic field is? Why does DESI use it, or other particle research people use magnets like that? Hmm? Hell, that's what it'll spill. How's Dr. Mallet doing with his time reversing machine? He seems to be knowing what he's doing, as well as Thomas Bearden, Ken Shoulders, Dr. Putoff. You know their stuff. Oh. I think this is well oiled up. Well, like another example, a cubic inch of different metals at different weights. Come on, something's going on, right? Oh, let's take a cubic inch of lithium, cubic inch of tungsten. There's quite a weight difference per cubic inch, isn't there? Right, for lead or gold. Right, do you know what Fermi levels are and balances? Everything's once plasma. Then to gravimetric tension, pull it into a sun. Sun spit out chunks of stuff, which formed plasma balls, and over time cooled down and created Fermi levels dropped. And started forming the atomic elements, right? And they joined each other and started forming other things. Inorganic chemistry and eventually organic chemistry and then human life and all that. Okay, so remember when you turn on your piece of plastic, what's going on there?